Let's look at how we can use the graph of the function f of x provided to arrange in the increasing order the derivative of that function at various x values. So we will be taking advantage of the notion that, or the idea that, the slope of the tangent line to f of x at x equals a is f prime at a. So let's start by looking at negative 1/2. So negative 1/2 is right about here. And it appears that the slope of this tangent line is positive. So f prime at negative 1/2 is positive. Let's look at f at 1. Here's 1. And so if I were to draw a tangent line to the curve at 1, it would in essence be lying on top of that line segment represented between 0 and 2. And so we can see here that the slope of the tangent line, or the derivative at 1, is negative. It's decreasing. Let's look at f at 3. Here's 3. If we were to be thinking about the slope of the tangent line for this segment of the curve, the tangent line would in essence lay across that line segment. And the slope of that tangent line would be 0 because it's horizontal. So we could say that f prime at 3 is equal to 0. Moving on, f prime at 6. Here's 6. So we're talking about the tangent line at this point. And if I were to create a tangent line to that segment of the curve, it would look like that, which is positive. So we can say f prime at 6 is positive, but is it bigger than, let's say, f prime at negative 1/2? So recall, f prime at negative 1/2, the slope would be the slope of that line, or the derivative would be the slope of that line, and f prime at 6, or the derivative, slope at this of the tangent line at 6 would be this line. So which slope is greater? Well, it appears that f prime of negative 1/2 is a steeper positive slope, meaning its value is greater. So not only can we say f prime of 6 is positive, we can also say that f prime of 6 is less than f prime of negative 1/2. And let's see, the last one we're to consider is f prime at 9. So here's 9. So looking up, we're considering the tangent line to the curve. Well, the tangent line to the curve in this instance would end up lying on top of the line. And that looks fairly steep. It's positive, so we can certainly say that f prime of 9 is positive. It does appear to be larger than f prime at 6, so we can say f prime of 9 is greater than f prime at 6. And then the question arises, which of the two, f prime at 9 or f prime at -1/2, is larger? They appear to be about the same. So we can actually, in the case of having a scale here, we can actually figure that out. So f prime at -1/2, if we do vertical change of 2 over horizontal change of 1, we see that the slope of the tangent line is 2. And here at 9, we have this line segment. We can do something similar. We can do vertical change over horizontal change. And for this line segment, it appears that f prime of 9 is equal to 2 over 1, or 2. So that means that f prime at 9 equals f prime at -1/2. So let's go ahead and complete the task we were given. Increasing order. So we want to go from negative values to positive values, so increasing. So there was only one point we were asked about that had a negative slope, and that would be f prime at f prime at 1. So f prime at 1 is the least slope. We only had one location where the derivative was negative. And then we can consider, where is the derivative 0? And we saw that f prime at 3 was equal to 0. So f prime at 3. So we've got -0. And now we're ready to start considering positive slopes. Increasing order, we want the smallest positive slope first. So the smallest positive slope would be f prime of 6. And then I can follow that with f prime of -1/2 and f prime at 9. So let's see, f prime at 6 and f prime at -1/2 and f prime at 9. Now technically f prime at -1/2 and f prime of 9 are equal, so they could be listed in any order. But here we have the derivative of the function at these specified values in increasing order. I hope this helps.